So yesterday we talked about graphing a quadratic function when we're given the function in expanded form. So we came up with 3 steps that we want to use. So the first step is to find the x-intercepts and plot them. The second step is to find the coordinates of the maximum or minimum point and then plot it. And the third step is to find the y-intercept and then plot it. And then we can use that to create our quadratic graph. So we're going to consider the example f of x equals x minus 4 times x plus 2 in order to drive this point home and help us practice it and generate a study guide that you can use in the future. So if we consider this function, first step, we want to find the x-intercepts and plot them. So remember that the x-intercepts happen on the x-axis. So if I have an xy grid, the x-intercepts happen along this axis, where the value of y, or the function value, is 0. So what we want to do is we want to take this function, we want to put 0 in for the f of x, the y, and then we want to solve the equation that's generated. So this is kind of small, I'll make it a little bigger. 0 equals x minus 4 times x plus 2. So as you guys remember from yesterday, that means that either one of these parentheses or the other has to be 0. So we can set up 2 equations. X minus 4 equals 0, or x plus 2 equals 0. So we get that x equals 4 when we add 4 to both sides there, or x equals negative 2 when we subtract 2 from both sides over there. So those are our x-intercepts. So we need to plot those. Remember, as a point, the value of y is 0, so it would be 4 comma 0 and negative 2 comma 0 that I need to plot. So we're going to go to the graph and plot those points, 4 and negative 2 on the x-axis. So step 1 is done. Now step 2, we need to find the coordinates of the maximum or minimum point and then plot it. So remember we said quadratic functions are always symmetrical. So if I look at the general quadratic function f of x equals x squared, it's symmetrical. So if we find 2 x-intercepts, like we just did, the maximum or the minimum point is always going to occur directly in the middle of those 2 x-intercepts. So if we take the x values that we got, x equals negative 2 and x equals 4, we want to find what number, what x value is directly in between those 2 values. So in between negative 2 and 4, we have negative 2 plus 4 divided by 2. That is 2 over 2, which is 1. And we could also tell that from a number line. If we think about the x-axis, 0, 1, 2, 3, 4, negative 1, negative 2. In between these 2 points is 1. So that tells us that the x value of the minimum or maximum point is x equals 1. Now, in order to determine whether it's a maximum or a minimum, we have to look at the constant term out front of the function. So in this function, it's f of x equals positive 1 times x minus 4 times x plus 2. We just don't write the 1. So that means that this graph opens up. If it was a negative number, it would open down like that. But since it's positive and it opens up, we're looking for a minimum point. So we're going to be finding a minimum here. So we know the x-coordinate at the minimum is 1, so we need to evaluate the function f of x equals x minus 4 times x plus 2. We need to evaluate that function at an x value of 1. So f of 1 equals 1 minus 4 times 1 plus 2. So that's f of 1 equals negative 3 times positive 3, which means that f of 1 is equal to negative 9. So the minimum point is going to occur at 1 comma negative 9. So we found the x value of the minimum point, and we evaluated the function at that value to figure out the function value, the y value. We got the point 1 comma negative 9. Any questions about that? All right, so the third step, the last thing we need to do, well, actually before we do this, we need to graph the minimum point. So we said 1 comma negative 9. So we go to 1, negative 9. We plot that minimum point. So the last thing we need to do now is find the y-intercept. So first we need to expand the quadratic function by using the distributive property. So this is our function, x minus 4 times x plus 2. So we need to double distribute, as we say, or use the distributive property twice. So we need to do x times x, which is x squared, x times 2, which is 2x, negative 4 times x, which is negative 4x, and negative 4 times 2, which is negative 8. So now we have f of x equals x squared plus 2x minus 4x minus 8. All we have to do now is combine like terms. So that's x squared minus 2x minus 8. So again, the constant term is what's going to tell us the y-intercept. Because remember, for a y-intercept, which happens on the y-axis, the value of x is 0 at any point along the y-axis. Right, so the y-intercept is going to be 0 comma negative 8. Because if I put 0 in for the function, I get 0 squared minus 2 times 0 minus 8, which is negative 8. Or you can just look at the constant term, the last term here, and see that it's negative 8. So the y-intercept has to happen at 0 comma negative 8. So now we plot that point, 0 comma negative 8, which is right here. And we have the 4 key points, the 2 x-intercepts, the y-intercept, and the minimum that we need to make our graph. So all we're doing now is just filling in the quadratic shape. Thank you guys.